All right, guys, day 2 of applications. Just going to see a couple of problems that are very similar to what we saw before. This first one involves Newton's law of cooling. It says the rate of change of the temperature of an object, so that's dt over dt, is proportional to the difference between the temperature of the object and the temperature of the surrounding medium. So that is K times the temperature of the object minus the temperature of the surrounding medium. So we're going to call that T naught. And that's like the temperature of the room. So just think of that, or this problem is talking about a pizza. So a pizza comes out of the oven, and the moment you take it out of the oven, it's going to start cooling down. And so this problem is going to put a math equation to how that happens. All right, so it says, suppose a room is kept at a constant temperature of 60 degrees. So 60 degrees is our T naught. And then the pizza cools from 100 degrees to 90 degrees in 10 minutes. Those are a couple different initial conditions that we will use to plug in our constants. Not plug in, but solve for our constants. All right, part A, find a formula for the temperature. All right, so this is going to be the solving of the differential equation. dt over dt is equal to K times T minus 60. Plugging in that 60 degrees for T naught. All right, now we're going to solve this differential equation. So we're going to divide by T minus 60. So 1 over T minus 60 dt is equal to K times dt. All right, so now we're going to integrate. And 1 over T minus 60, that's a T to the first power. So we get a natural log absolute value of T minus 60. And then integral of a constant is just that constant times a variable. And then don't forget your other plus C constant that we get from integrating. All right, so we have two different constants we have to find, and that's why we get two different initial conditions over here. So I'm going to start with the first initial condition, that it is 100 degrees right when we take it out of the oven. So that's like 0, 100. So I'm plugging in 0 for the lowercase t for time, which is going to cancel that term out right there, leaving us with C. And I'm plugging in 100 for the temperature T. That's going to give us ln of 40. All right, so our first constant is the natural log of 40. So ln of T minus 60 is equal to KT plus the natural log of 40. All right, now we need to find the other constant, the K. So that's where this second one comes into play. And it says 10 minutes later, it's down to 90 degrees. So that's like 10, 90 as our other initial condition. All right, plug in 90 here. We get natural log of 30. Plug in 10 for T, so we get 10K. And we have our plus natural log of 40. So subtract that over, and we end up with natural log of 30 minus natural log of 40 equals 10K. And then remember, these can be combined into a single natural log by dividing the 30 divided by 40. So that reduces to 3/4. And we're going to divide by 10 to get K by itself. All right, so our equation and the answer, well, not quite the answer, but our equation that we have now is natural log of T minus 60 is equal to the natural log of 3/4 divided by 10 times T plus the natural log of 40. All right, so now we need to get T by itself. So we're going to exponentiate everything. All right, so those just cancel out and we get T minus 60. I'm going to go ahead and drop the absolute value bars now. You can look at our initial conditions and see that we're not going to get a negative number inside here. So we can just forget about the absolute value bars. All right, then we get e to the natural log of 3/4 over 10 times t, and then e to the natural log of 40. So that e to the natural log of 40 becomes a 40. We have the rest of our exponential. And then we're going to add the 60 over as well. That is going to be our answer for part A. All right, part B says, after how many minutes will the temperature of the pie be 80 degrees? All right, so now that we have a temperature equation, we can do part B, which is to plug in 80 for T and solve for the lowercase t, the time. All right, so we're going to subtract 60 over here. We're going to divide by 40. We're going to take the log of both sides to cancel out our exponential base. So we get log of a half equals natural log of 3/4 divided by 10 times t. And then we just finish up by multiplying by the reciprocal of that fraction. That'll get t by itself. All right, so we end up with t equals, and we pull up our calculator. Get rid of that. All right, so we have natural log 3/4 it was actually a 10 on top, wasn't it? So 10 over the natural log of 3/4, and that's being multiplied by the natural log of 1/2. And we get 24.094. And our units are in minutes. 094. All right, and once again, just make sure that this makes sense in the problem. It took 10 minutes for the time for the heat to go down from 100 to 90. So we know that our answer should be bigger than 10. And it's not linear, so it shouldn't take 10 minutes. 10 degrees doesn't equal 10 minutes every time. It's a curve. So the fact that it takes 14 more minutes here to go another 10 degrees still seems like a reasonable answer in this problem. All right, our next one does not involve Newton's law of cooling. So if you want to pause the video here and give this one a try on your own, I would encourage that because it involves a lot of the same processes. All right, so the population of a certain town increases at a rate proportional to the square root of the population. All right, so part A, we're going to need to solve for what is the population in t years. So dp over dt, that's our population rate, is equal to k times the square root of the population. So divide by the square root and multiply by the dt. Time to integrate. All right, this time we do not get a natural log. We have a p to the 1/2 power, actually p to the negative 1/2 power because it's on the denominator. So no natural log, we just use the power rule here. So if we add 1 to negative 1/2, we get p to the positive 1/2. And then we would divide by 1/2, which is the same thing as multiplying by 2. Over here, we just get that kt, and then don't forget your constant of variation. All right, so now we're going to plug in our initial conditions. So the population goes from 900 to 1600 in 4 years. So once again, this is 2 different initial conditions. All right, we have 0, 900, and then we have 4, 1600. All right, so starting with the 0 one. So that's going to zero out the kt part, giving us c. And then this is 2 times the square root of 900. So the square root of 900 is 30 times 2 is 60. So c is 60. All right, so let's rewrite our equation. 2 square root of p is equal to kt plus 60. All right, now we'll plug in the second initial condition to find our k. So that one was 1600 for p equals 4k plus 60. All right, so square root of 1600 is 40 times 2 is 80. Subtract that over, 20 equals 4k, so k equals 5. All right, so now to finish up and get our equation for p. So 2 square root of p is equal to 5t plus 60. Divide by 2, square root of p is equal to 5t plus 60 all over 2, and then square everything. So p equals, so I'm going to square the top part in parentheses. So 5t plus 60 squared then I'm actually going to square the bottom. 2 squared is 4. You could just put the whole fraction in parentheses and put a squared. That would work fine as well. I think this will be a little easier to work with. All right, so let's see what they want on part B. What will the population be at the end of 10 years? All right, so that's plugging in 10 for t. Round your answer to the nearest whole number. All right, I'm just going to do it right over here. So P equals 5 times 10 plus 60 squared all over 4. All right, we could plug this in the calculator, but let's see what we can do here. That's 50 plus 60, so that's 110 squared over 4. So we need to do 110 times 110. 1, 0, 0, 0, 1, 1. All right, so we had 0, 0, 1, 2, 1. 121, or 12,100. All right, and then if we divide that by 4, so that goes in there 3 times. 4 goes into 10 2 times. 4 goes into 25 times. So it looks like we have 325 people. No rounding necessary. All right, and I made a slight error here. So when I was dividing, 4 goes into 12 3 times, and then I had a 1 left over. So 4 goes into 1 0 times. So it's actually 3,025 people, not 325 people. All right, and that'll do it. So give those worksheets a try. Come to the Google Hangouts, ask some questions, and I will see you all for the next one.